Question 6 comes in many parts. The first part asks us to show that 1 over root n is less than 2 times the difference between root n and root n minus 1. How do we do this? Well, this is 1 over the square root of x graph. Well, if we look at this box in here, what's the area of this box? Well, the base here is of width 1. What's the height? Well, we look at the point on the y-axis. This is above n, so this is 1 over square root n. So the area of this box is going to be equal to 1 over square root of n times 1, or just 1 over square root of n. Right? What about the area under the curve? What's that going to be equal to? Well, that will be the same thing as the integral from n minus 1 to n of 1 over the square root of x dx, right? That's the same thing as 2 times the square root of x between n minus 1 and n. And what do we get there? That is equal to 2 times the square root of n minus the square root of n minus 1. Now, comparing the two areas, the area under the box and the area under the curve, which one's bigger? Well, clearly the area under the curve. So we can say area of box is less than area under curve. Therefore, 1 over root n is less than 2 root n minus root n minus 1. From this we're asked to deduce that if we summed up all of our 1 over root n's, it would still be less than 2 times the square root of n. So let's see what happens. What happens when n equals to 1? What does that give us? That tells us that 1 is less than 2 times square root of 1 minus square root of 0. What about if n equals to 2? It means that 1 over root 2 is less than 2 times root 2, take root 1. N equals to 3 tells us 1 over root 3 is less than 2 root 3 minus root 2. N equals to 4, 1 over root 4 is less than 2 times root 4 minus root 3. Are you guys seeing the pattern? What about the last one? N equals to capital N tells us that 1 over root n will be less than 2 root n minus root n minus 1. And here we can see that method of differences is going to kick in, so these are all going to cancel as I add up this left-hand side. So, therefore, by method of differences, what can I say? I can say that 1 plus 1 over root 2 plus 1 over root 3 plus all the way up to 1 over root n is going to be less than, because that's the way all the signs are pointing, and then 2 root n is left, minus 2 times root 0, which is 0. So this is, that we can ignore, and then this is exactly what I was asked to show. So, no worries there. What about in the second part? What am I asked to do? Second part looks similar, except my curve is, I have to set this up slightly differently. Instead of having my curve between n and n minus 1, I look at n and n plus 1. I look at the area of this box. So, what's the area of this box? Well, the width is 1, that's fine. What's the height? Well, if we look across, this is at n, so the height is 1 over root n again. So the area of my box is equal to 1 times 1 over root n, which is equal to 1 over root n. What about the area under the curve? Well, the area under the curve will be equal to the integral from n to n plus 1 of 1 over the square root of x dx, and we know what that is from our previous part, and then we substitute in our values and we get root n plus 1 minus root n. And so again we look at these two and we can say quite clearly that the area of the box is bigger than the area under the curve this time. Therefore 1 over root n is going to be bigger than 2 root n plus 1 minus root n. And then we have to do a similar thing as we did last time. Works almost exactly the same way, still method of differences. N equals to 1, what do we get? 1 is bigger than 2 root 2 minus root 1. N equals to 2, what do we get? We get 1 over root 2 is bigger than 2 root 3 minus root 2. N equals 3, what do we get? We get 1 over root 3 is bigger than 2 root 4 minus root 3. What about when n equals to capital N? What do we get? We get 1 over root n is bigger than 2 root n plus 1 minus root n. And we can already see our method of differences here. These will cancel, 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 cancel. Right? We'll now add these all up. So therefore, by method of differences, what do I get? I get 1 plus 1 over root 2 plus 1 over root 3 plus all the way up to 1 over root n is going to be bigger than 2 times square root n plus 1 minus 2, which is what I'm left with up here. The last part asks us to find the smallest n such as this summation is bigger than 1,000. Well, we know that this summation is going to be bigger than 2 root n plus 1 minus 2. So if this is bigger than 1,000, then that's we stand a good chance of being able to find the n that we want. So we solve this inequality here, and we get 2 root n plus 1 has to be bigger than 1,002. So root n plus 1 must be bigger than 501. And so n plus 1 must be bigger than 501 squared, which is 251,001. So n must be bigger than 250,000. So the smallest such n would be 250,000, or rather we should start checking from there. And as it turns out, this n works, so this is our final answer.